Hackaday Prize Dream Team Initial Concept Presentation. Today we have the UCPLA United Cerebral Palsy Los Angeles Dream Team joining us, along with their expert panelists from the UCPLA team. We're going to get started with a brief introduction to why we're all here today, and then we will launch into presentations and discussion. My name is Magenta Strongheart. I'm the head of design and partnerships at SupplyFrame's Design Lab. For those of you who don't know, SupplyFrame is the parent company for Hackaday, Tindy, and Design Lab. Design Lab is our 4,000 square foot design and fabrication facility right outside of Los Angeles, California. And this year for the Hackaday Prize, we're doing something totally new, which is the Dream Team program. We essentially recruited top talent to work with our nonprofit partners to help solve a challenge over the course of a 2-month engineering sprint. So we have 3 innovators joining us who are part of the Dream Team for UCPLA. We can't wait to introduce them and see their initial concept presentations. Today's going to work where we're going to have a 20-minute presentation by the Dream Team and then 20 minutes for discussion between the panelists and our Dream Team members, and then finally 10 minutes for Q&A from the audience. So if you are tuning in right now, please drop your questions in the comments section, and we'll be sure to integrate those into our discussion at the end. Before we get started, I just want to give a huge thank you to our sponsors, DigiKey, Microchip, SupplyFrame, and ARM. Without them, this would not be possible. So we're so grateful and appreciative for their support to continue this amazing work and to develop incredible open source solutions for our nonprofit partners. With that, I'm going to pass it off to Giovanni Salinas, our product development engineer, who's been project managing these teams and who will give you an introduction to the challenge that the UCPLA Dream Team put forth.
Thank you, Magenta, and hello, everyone. I am really happy to be here today for the first abstract and concept review for the Dream Team Challenge. The UCPLA team includes Kelvin in Toronto, Canada, Ruben in Colorado, USA, and Natalia in Boston, USA. So hi, guys. It's great to see you here. Now, the UCPLA Challenge asks the team to design a new type of universal remote that meets the needs of the physical challenges of people with cerebral palsy and integrates with modern electronics like smart TVs, workstations, and other digital devices in as few steps as possible. Now, while the definition of this challenge sounds narrow, in the world of usability, it becomes really broad. So additionally, one of the biggest and more frustrating challenges is cost also for this kind of devices. So after a lot of research and trying to understand the user's challenges, the team reinterpreted it to developing an affordable open source platform to democratize assistive technology for interacting with the digital world. During the first 3 weeks of work, the team has done a lot of research in the field and started brainstorming potential solutions. The idea of today's meeting with Stephanie and Rania is to present the results of this research and start discussing our first ideas. Stephanie and Rania, we cannot thank you enough for being here today, and we are really looking forward to hearing your feedback. So without further ado, I'll pass it on to the team.
Hello, I'm Ruben Kexter, and I'll start the presentation, which I believe is this one. There we go. Can everyone see my screen? Very good. So
yes, we can.
Thank you, Giovanni. We're going to start with a simple overview of the project. We're going to go through a simple introduction, building off of what Giovanni has already said. Touch on our design goals, and then go over each of the platforms that we feel that as if we could bring them all together, could be the ultimate remote to solve all the problems. Our big mission, as said before, is to develop affordable open source platforms that can bring assistive technology to everyone in the world, everyone who needs it, at an affordable price. Our potential users have such a drastic range of disabilities that it was a real challenge to try to figure out what to focus on in the short time that we have. And our target devices in this day and age can range anywhere from a simple TV controller that was around 50 years ago to autonomous cars that are coming out. Our design goals are centralized around these few points. We want this, again, to be a universal control interface with as many connected devices as possible, at least those that our users want to interact with the most. Accessibility, it needs to be easily usable by anyone, especially users with disabilities. Portable, it needs to be able to have a long battery life or be able to charge easily and even be mountable on whatever mode of transportation our users will be using. We would like it to be expandable and integrate with as many different input methods as possible. As again, the range is a drastic range between different usabilities that whatever we decide needs to be able to adapt to our users. And with that, it needs to have functions and actions that are customizable so the users can pick and select and lay out whatever this is to meet their needs. As mentioned before, the cost is a big factor, especially in the world of accessibility, and we'll cover that more in the other concepts. And durability is a huge factor too, as users that have disabilities may apply too much force, and so it needs to be very durable to be able to stand up to the user's constant use. Our platform essentially wants to be the middleman between two worlds, the physical world where the user interacts with different kind of input methods, and the digital world, which is increasing and growing at a rapid rate. And there's so many awesome projects out there, but how do you interface with them? Hopefully we'll find a way to bridge that gap. This is one proposal we came up with, and it's adaptive smart remote. So sticking to the name of the remote, what if we could make a remote that could be truly used by everyone? Target users, in this case, we're targeting users that cannot use existing devices without lots of effort. They would need some sort of accessibility. It works best with someone that has a line of sight with the device so they can see the buttons and things they're touching. And with touching, they need to be able to use some sort of digit, a knuckle, a hand, a fist, a toe, something to interact with it. And again, we are assuming our users want to be able to use and operate this device independently without be able to get it out and use it and move it around and be their companion as needed. Concept goals for this proposal is a versatile, low-power device usable right out of the box. No additional device or supporting platforms required. At its bare minimum, we hope to get it out and be able to control a TV. This kind of interface would be easiest and intuitive for users with limited mobility. It would have unlimited functions by using a display to show users what functions are currently assigned to each button. And then you can design it and customize it to your heart's content. Options are infinite. We want it to be integratable again with existing devices, easily expandable, so touching on meeting a lot of our target goals. Easily expandable with different physical input methods. And in this case, we could even include a speaker that could be added for additional feedback and options. One option would be users could use the device as an assistive communication device, where each button may say or say something or a word or a phrase to help them communicate. An original concept of this has existed and has been tried, and the users are super grateful. The caretaker and the primary user absolutely love the idea. While it needs some improvement, they are really grateful to have something in their life, anything to help ease the struggle. And now it's time to bring it to the next level. In this case, we're trying to the concept be as simple as, here's a screen, it's a TV remote. Let's say we want to go to another screen for more functions. If the user presses the far right button, the button on the display would highlight and it would bring another screen. So here the possibilities are endless. They can flip through a book or page-like platform and program and add as many pages as they need and want. Again, for customizability and expandability, you could orient it in any way that makes best sense for the user, right-handed, left-handed. On the right-hand side, we're showing examples of adding external buttons or joysticks or other input methods if the onboard buttons aren't quite, or we would need more options. Some variations, possibly variation 1 would help alleviate the issue with people that don't have that line of sight required to use a single system. The display unit could be the main system mounted somewhere up higher in their line of sight, and then the buttons or other inputs wouldn't have to be this grid, could be wherever they would like it. Another variation 2 we could thought of is, what if the buttons had the displays built in? That option looks more like a universal remote and would be smaller, more portable. It comes with its own challenges. And now I'll turn the time over to Kelvin for the next proposal.
Hi, thank you, Ruben. For this next proposal, I want to build off of Ruben's modular expandable concept and focus on developing a joystick-based module for operating computer workstations and accessing different computer programs such as Photoshop for expressing creativity, web browsing for gaining knowledge or connecting to online communities, or video games for recreation. Common input devices are mouse and keyboards, and they're not easy to use for a majority of this population, so they might prefer something more familiar, such as a joystick. Next slide. So it seems existing joysticks are a popular input device for this community, and many users operate their motorized wheelchair with a hand-operated joystick. So for our solution, we want to present something that has a familiar, intuitive interface, so it's more likely for users to adopt and use. So then we ask the question, why don't a lot of users have assistive joysticks for accessing computers or tablets right now? So when we look at looking at existing consumer products, they do exist, but it's just often at a ridiculous price point. So for example, the Bluetooth joystick for a tablet and phone that exists costs about $1,200. And if we're trying to identify the biggest accessibility barrier that restricts individuals with cerebral palsy from accessing the digital world, that barrier just might be the cost itself. Next slide. So one approach that is pretty straightforward from our end is to just focus on overcoming this cost barrier. To develop a low-cost Bluetooth joystick that can connect to computers, tablets, or phones. The first step would be to identify off-the-shelf electronic components to make a Bluetooth joystick, including a joystick handle, a Bluetooth microcontroller, and a few buttons. What we want to focus here is on low cost, aiming for a target of under $50, something that's easy to assemble, and something that is easily reproducible by others. So by the end of this project, a very feasible goal would be to deliver a few standard functioning Bluetooth joysticks. And then we can take this a step further to address ergonomics and make unique joysticks for each individual user. Next slide. So after we've identified the main electronic components to make a DIY joystick, the next step is to focusing on mechanical components that affect ergonomics, mainly the joystick handle. So similar to how you guys have developed a digital library of 3 principal parts for attaching painting tools for painting, we could do something similar for the joystick handles with different designs that are adjustable for different user grips, also different hand sizes. So for a lot of these existing products, first of all, they're really expensive. So these handles could be like $200 for a piece of plastic. And they're also pretty generic, as they're made out of pretty simple basic shapes. And they're all designed very symmetrically. So not very tailored toward individual people. So for each individual user, we could loop them into the process so that it's more likely for them to embrace the solution and use their custom tool. You could ask users to try different joystick handles and identify which one they can grip best. Ask them for their input on their button sizes or where their preference would be for button placement on a joystick platform. Then we could use digital fabrication tools like 3D printers in your studio that you can use to create unique joystick platforms that is tailored for each person. So our job here is to identify the correct parts, come up with a DIY joystick kit, and to come up with an easy-to-use instruction manual for assembly and modifying 3D printed parts. For this approach, the goal isn't to deliver just a generic joystick model, but rather to teach you guys a simple process for reproducing low-cost, unique Bluetooth joysticks. Next slide. So switching gears a little bit, another approach that we want to explore is a new type of joystick that senses user motion that is both durable and user-friendly. The easiest way to explain this concept is by looking at the Wii remote, where you can control actions and play games by waving the Wii remote around. So with this system, the goal would be to control digital devices by detecting motions of the user that are within the natural motion of the user. This would be a joystick in a wireless small package that can be worn, that is attached to different parts of users' bodies based on their preference. So the three images on the below, I've had like a wireless joystick that I attached to my hand, my wrist, and also my knee. Next slide. So here's one example of how a user might use this type of joystick to replicate the 4 directions of wheelchair movement: forward, backward, left, and right. So here I have a motion sensor attached to my wrist, and I'm wearing it like a watch. So if I were sitting in a wheelchair, my arm and my elbow is pretty much like on the table, which is sort of like on a armrest of a wheelchair. So in this position, I'm using my elbow as a pivot point for my joystick. So there's no longer a second physical joystick device. And in this case, the joystick is my arm itself. So intuitively, if I wanted to move left or right, I would swing my arm left or right from a neutral resting position. And if I wanted to go forward or backwards, I would similarly move my arm up or down. Next slide. So for more examples of this concept, I've uploaded 2 YouTube videos that are linked into the abstract that we've attached. In this scenario, I'm holding 2 motion sensors in both of my hands, and I'm using these sensors to control mouse and keyboard commands, such as moving the mouse around or clicking the mouse for the application of drawing in Paint. So the 2 images on the right are drawings that are drawn only using these motion sensing joysticks. So I drew the supply frame logo with both my hands, and I drew the happy face by moving my head to demonstrate the ability to control with different body parts. So with that, I'm going to pass it off to Natalia to present a different concept.
Thank you, Calvin. Thank you, Ruben. And finally, our final Slick proposal is a platform app. And obviously, you might immediately ask, why do we talk about any apps after these amazing contributions and ideas for the hardware? But I'm going to make a case that application and software basis is interconnected, not only for Calvin's and Ruben's applications, but for thousands of hackers from Hackaday and all around the world. Next slide, please. So why do we even talk about software? Well, first of all, it's the cheapest solution for the production once developed. It is the easiest to distribute, no shipping cost, no 3D printing errors, no components missed or out of stock. It is potentially the easiest to adopt and to test with the existing devices our users own, as the availability of these devices is possibly the highest as they are ubiquitous. Among existing reports, interviews, Google Forms we have leveraged and collected, as well as feedback from the UCPLA team. Almost all of our users, potential users, own a smartphone, a tablet, or an assistive vocal support system. Next slide. And obviously, even going beyond, with the ubiquitous communications and systems available all around the clock, even if our actual users do not have a system at play, their caregivers, their homes, their centers have an Alexa Echo, Cortana, or smart home appliances that are already connected. We can leverage all these devices in the support of our users. Next slide. Here's one of the supporting quotes from the users and from the UCPLA team members. Individual utilizes all of the above, smartphone, tablet, etc., as they're also consumers of the times. But what is really lacking is the how-tos. Can they utilize these items to fit their unique physicality? There are no other examples of these either through apps or videos. Another responder from our survey suggests that he's like watching YouTube, but unfortunately, it's a bit hard for him to actually find these videos that actually can support his condition as a condition of other people as him. Next slide. So what we have done already preliminary, we have actually leveraged a first version of our survey where we ask very different and broad questions. Sometimes they're very precise and sometimes not. For example, if you can install any any dream app of your choice. What this app would be, what would it do? Or what applications are you using at least once a day, like WhatsApp, Facebook, or Instagram? And based on these responses, our platform app can leverage a suggestion for our user. Next slide. Here is an example. Let's imagine Tommy. Tommy used our service system within an app or a web interface. And our platform app will generate a response. For Tommy, the best option would be to set up an open source smart home system from OpenHub, as the smart appliances control is requested by Tommy very often. He mentioned that his preferred communication method is voice, and the second preferred is touch. Tommy can either check for, and our platform will suggest, this offer from Amazon Echo for $39 with tutorials excluded or not available, or this amazing Hackaday project from 2020 Dream Team with a cost of $50 with 3 already available tutorials for the smart home systems, and maybe with other users posting the tutorials on the Hackaday. Next slide. There are several main features. The versatility and personalization based exclusively on the desires and capabilities of this current user. Can they touch? Can they speak? Can they produce sounds? Based on the existing open source or commercial product that the user owns or wants to own. If they already have Alexa, let's leverage it. If they already have a joystick, let's leverage it. Checking for tutorials and videos to help the user in their condition, not just, oh, start using iPad tutorial. Learning curve could be very short to non-existent, depending how acclimatized the users are with the apps, and because they have the devices, usually they are pretty acclimatized. And this system is extremely incremental, potential of easy integration with the suggestions from Sarah, Alex, Ruben, Calvin, as well as other thousands of hackers, researchers, and designers, as well as center team members. Next slide. In a nutshell, in a perfect scenario, there are actually no limitations. This platform can ultimately enable access to any device, joystick, tablet, wheelchair, headband, to any modality, voice or touch. It can be accommodating for any budget. Maybe you already have it, or maybe you have some availabilities and capabilities to pay. And as well as any system, even the ones that already purchased by the users for any other needs. And potentially going beyond cerebral palsy, accommodating other disabilities, at least similar ones. Next slide. Obviously, there are a lot of challenges to overcome. The database should be built and constantly updated, as it might require some support from a full-time or part-time person at the center, at least in the beginning. But community can also leverage this easily. It might require, obviously, some additional generation of the contact in case of the user who cannot feel touch or cannot speak or cannot actually hear. This contact should be generated in the modality they can hear and understand. Obviously, privacy concerns are also important. Next slide. Obviously, here is a big and honest vision of how we can see this platform. The best case scenario would be the creation of the unified platform on multiple US states where UCP exists, to include multiple centers, expanding into the worldwide use and creating the unified database with great stats available. In the medium case, we will have our counties, our local centers, and also available for statewide use. And in the worst case, even if we have one Tommy being able to tell me, Natalia, a researcher, what he's looking for and what are the options he's looking for, I can just give him a feedback. Hey, maybe you need to go on Hackaday and check this and that project. Next slide. So this is obviously not a final representation, but a potential vision that Tommy can control his system using like his voice, gestures, or even brain. He can watch, read, and listen how to acquire some systems, how to buy them. He will know that he already has some parts of them. For example, if he uses his voice, like Alexa and Cortana will explicitly tell him this. He can maybe participate in some paid studies, and he will actually be able to learn about his condition of other people and connect with them. And finally, for example, if the gesture system is not supported yet, but a system was readily available for the UCPLA center, who has most of the components, or the supply frame can supply them with a budget that is very, very limited. He can actually address to these centers to help them build the system. And on this one, and Ruben, you can move to the final slide. We want to thank you for your attention. Right now we are taking questions, comments, and feedback. And of course, do not hesitate to contact us offline if you have any remarks and questions. And on this note, I will pass to Magenta.
Wonderful. Wonderful presentation. Thank you so much to the UCPLA Dream Team, Natalia, Ruben, and Kelvin. That was awesome. And I'm so excited to hear the feedback from our panelists. We have Stephanie Anderson-Stott, Director of Growth and Innovation at UCPLA, and Aranya Kerr, Adaptive Design Manager for UCPLA, with us today. And they've been given so much of their time, so much generous feedback and mentorship to all of our Hackaday Prize entrants this year, and especially our Dream Team members. So want to give a huge thank you to them first off. And in just a moment, we'll pass it off to them for their questions and feedback. I do want to remind our audience members right now that you can comment any questions you might have for our panelists and team members here today in the YouTube comments here, and we'll be sure to gather those before our Q&A for the last 10 minutes of today's event. So without further ado, we'll start our 20 minutes of discussion, and then we'll wrap it up with your audience comments and questions. Go ahead, Stephanie and Aranya, if you want to take it away.
To start out, we want to thank Hackaday and Supply Frame for supporting this incredible challenge, and to the innovative members of our Dream Team. You've brought even more than what we could have imagined up to this point. So this is a very exciting day for us as we look through all of the opportunities. First of all, let me just say that it is amazing to see that the spectrum of solutions that you've proposed really track and meet the spectrum of needs. Okay, you seem to have developed options and opportunities for such a diverse group of people and users. And that's extraordinarily heartening for Aranya and I, as we have met and seen so many creative and very capable people who simply need greater adaptivity in terms of what's available to them. And I'm quite blown away by some of the suggestions already. I'm very excited not only to see what you've presented, Ruben, related to the joysticks and some of the equipment that people are already most familiar with, but also to really take a look at the idea of utilizing the motion sensors, Kelvin. So many of the individuals that we work with definitely have certain types of range of motion that they are very able to control and manage and are very natural to them. Being able to leverage that and be able to give them more control in all sorts of activities in their everyday life would be significant. Likewise, Natalia, it's great to look at the opportunities related to the apps, as that's going to be such a diverse and accessible platform. I wanted to start off just with a quick question with regard to the motion sensing equipment, because that's something that I know even less about. What would the price point be? Do you still think that that's going to be something that might be able to be produced in that kind of $50 range or something along those lines?
Yeah, so the initial prototype that I was using, I had like 2 motion sensing units and also a migraine controller. And in total, it was about $30.
Great.
So that's sort of the price point that we're starting with. So it's still like similar to like the other like joystick, open source joystick that we might want to look at developing.
That's tremendous. That's tremendous. Aranya?
Yeah, I mean, first of all, I think everything was like pretty amazing. So thank you guys. That was so awesome. And for you to consider everybody, like the spectrum, it's, you know, I think my wish now is like, I want to see it happen, you know, I want to see it made, you know, so it's like, that's my excitement, is knowing that it's brought to this point. Now I want to see like the production and like have the users use it, you know?
I'm also quite blown away by the price point. You hit on and heard our concerns about the exorbitant costs of so many of the devices and the technology out there that's outside of the reach of any of us, let alone people who were on a very fixed income. And to be able to not only make things fairly inexpensive to be able to obtain, but to also replace is huge.
Yeah.
Also, to not have it caught up in the politics and challenges that come with insurance systems, and things that have to go through many different doctors and consultants and whatnot is huge. As you said, democratizing the digital tech and increasing the accessibility, it's huge. It's a huge step in terms of
and also just like individualizing to any user that uses it. Like everyone has their own language, so like I think that's like really powerful that they could create their own language in these controls and then be able to use it. So I think that's like really important, because at the end of the day, it's theirs, it's not ours. So yeah, you guys are amazing.
To that end, the idea as well that the individuals could influence the way that their unique piece of equipment might be able to be utilized. Ruben, as you were talking about with the joystick and the different types of grips, that's, again, very exciting to see, because the idea is to be able to conform to the individual needs and capabilities of people who have, unique physicality. Each one of the platforms suggested, from the joysticks to the motion sensors to the apps, offer a range of those options. But it's exciting too, because each one is so scalable, I believe. And just as you had suggested in your design goals, expandable, depending on the different types of things that people would like to do with the equipment. Let's see. Questions, I probably have a million, but let me drill down a bit. Aranya, do you have anything right away?
No, I mean, I don't really have any question. I just like, I love the idea from like the physicality to like the app part to like how the user will use it, and that can kind of create like a discourse amongst other users. So I think that's like really like innovative. It's not just about having that product, but it's also having like the apps to go with that product, and then having a multiple conversation or a universal conversation.
Yeah, the potential for interfacing with so many different points of interest in people's lives is huge. Let me ask you, along the lines of the motion sensing, it would seem that there might be compatibility also with eye gaze technology. We, definitely know some folks who utilize calibrated eye gaze technology to be able to control everything from their wheelchairs to communication devices. Does that seem something that would be in line with what you're envisioning or developing as an option for motion sensing technology?
So I believe like the eye tracking, eye gaze solutions are like oftentimes camera based.
Okay.
So I don't know if it's as easy to integrate. It might be like a separate solution.
Okay.
Another thing is having like a motion sensor like attached like somewhere on the head where you're like moving. I think that's somewhat similar if it's like slight head movements to sort of control like different choices.
I can jump in actually and back it up a bit, because I did develop several eye tracking systems that are not camera based. So it's important to mention that there are camera and non-camera based systems. Obviously, we do lose some of the features. So features like capabilities of the system. Camera based can tell you, for example, pupil dilation, and usually they're extremely precise. But there are several drawbacks. One, very important, even open source are extremely expensive. I haven't seen a lot, like on Hackaday, I saw a couple that tried to actually nail it down to cheaper versions. And that's why actually a lot of people still try to hack and just attach camera and I'm due to the glasses, just to sunglasses to any frame, like super cheap one. So that's one direction. The thing is that obviously at night, if the sensor is not fitting well, you're tired, the classification outcome, like the precision would be a bit lost. But we have also developed, particularly focusing on the privacy and ethical considerations for other users, non-camera based approaches. So there will be maybe less features, meaning less options, but it can be like eye blinks, for example, moving eyes left, right. So we can associate those potentially. And these are very, very affordable. They do go under definitely 200 off top of my head. And I believe that with some maybe external like research, they can definitely go even cheaper. Obviously, cannot go like, cannot say right away 50, but definitely I think under 200. And what is more important, a lot of these systems do have IMU and other sensors already built in, and they weigh like 20 grams, something like Aranya's glasses that I see right now. I'm pretty sure it's like 20, 30 grams weight. So that would be actually very, very light here. So there is options, no precise, I would say, right away, but yeah, there are directions we can also explore.
That's wonderful to hear. Again, just looking at, you know, what some folks have been able to really utilize and incorporate into their lives over time, just to see, you know, different types of applications. That's great. Thank you. Thank you very much. Oh, with regard to what can be 3D printed, as probably the only person in the group who isn't a very strong 3D printer myself. Can you tell us a little bit about with the motion sensing equipment as well as with the joystick, what you see as being able to be easily reproduced and printed, you know, potentially by folks in our studios, and what would be things that would need to be supplied?
So for the idea of like a joystick platform where you have like a joystick and a bunch of buttons that are Bluetooth connected, I think the main like ergonomic feature that's most important is the handle itself. So I think it's the handle that we would like to have like a library of different parts that for different users that we want to develop. And it's also like another part which is not as important, but it's also like the platform and where like the buttons would go on the platform that would suit each person. So I guess those are like the two components that we want like user input for designing a joystick platform.
So if there was the base compatible configured equipment, then you could add on those pieces and print them directly according to each individual and have them available. Okay. I mean, that would work very well with how we're set up currently. And also to just touch on the fact that there are so many other providers, as you mentioned, across the country, many of whom that we are connected with. Some are other UCPs, which is a national organization and has affiliates across the country, but also providers of other independent nonprofits that we know need this kind of technology and would enjoy being able to experiment with some of these prototypes and be able to give feedback. So there's a huge number of people out there, and then way beyond even our own network, I'm sure that this could benefit. So thank you. Aranya, do you have anything else?
Yeah, I mean, I think the idea of all the different joysticks are like, again, that's very personal and that's very individualized, because every joystick that's out there, you know, you just got that one basic one, but some of them use like their like wrists to kind of move the joystick around. So that big one was like really cool. So, I mean, you know, basically you guys thought about everyone's physicality and kind of like the spectrum, and then kind of adapt all these different like, you know, set of things that go to everyone. So I think that's like really interesting. So yeah, that's awesome.
It's also interesting. I would just a little bit more feedback. The notion that you've got these different platforms offers a user who has different capacities to use them based on how they're feeling. We talked a bit about in some of our conversations about you know, just the fact that exerting a lot of physical motion can be very tiresome. And so at the end of the day, the physicality might decline, but somebody might be able to rely on blinking, as you were saying, Natalia, or just making sounds to control something. So again, having these multifaceted options and solutions.
Or just kind of like time, you know, how the body kind of like not deteriorates, but just kind of loses some of the functionality. And so these are the different options as time, you know, takes over, then they can again, they're not losing their ability. They just need more adaptation. And some of these things will like fit into that adaptation.
Absolutely.
And one of the things I wanted to mention, correct me if I'm wrong, team, we're still waiting for results of the surveys, right? And based on those findings, the project might go in one direction or the other, right?
Yes, so just to give super quick update, because folks from the outside on YouTube obviously do not know, but I tried to mention it real brief. We rolled out a first version of the survey, and the actual very quick feedback that we got, as I said, we worked like 60 plus questions, very, very, very long and full one. And the very first feedback we got from Stephanie and Ryan is super useful, saying that, hey, you know, it's amazing, but we don't work only with cerebral palsy, like it's exactly your last point, Stephanie and Rania. There are other similar and sometimes not similar at all disabilities and conditions. It's exactly what we are talking about. So ultimately, we might even expand it, our survey, changing a bit the language and adapting it to actually more generic disability. So some links provided for the apps are actually included generic disability and not only CP. But it's an excellent point from you, Stephanie and Rania, saying that with time, even us, we are not as fresh at 9 a.m. as, like, for example, at 7 a.m. or 7 p.m., etc. And obviously, there are disabilities and conditions where it is unfortunately degenerative deterioration like ALS, and there are no way back, no comeback. So definitely, if we can also meet these users potentially halfway, we're not saying that we're going to design everything in 2 months, but definitely this is a big, big vision and direction which we would try to shoot for, at least, and with the help of the folks and the team.
Well, and again, the incredible advocacy to be able to empower people to be independent in every aspect, any aspect really of their choosing in their lives is significant with this project. Thank you for taking that on. Thank you on behalf of our organization, and I believe so many others out there who are absolutely yearning to be able to leverage their great knowledge, their capability, their ideas, their voice in different ways. This is tremendous.
I'm sorry, I'm gonna have to cut off our discussion there and turn to our questions from the audience. We have some amazing questions coming in, so I want to make sure we allow for enough time to answer those. Thank you, Stephanie and Aranya, for your feedback and insight, and I'm excited to see what our team has to say to some of these comments. So let's get started here, and I will ask to the Dream Team members if you could try to be as concise with your answers here. Maybe leave it up to one member to answer each question, just so we can get through them. We have about 6 collected here, and there might be more coming in. So I want to get to as many as possible in the remaining time we have. All right, so first question, are there any plans to integrate haptic feedback to the wireless joysticks?
So yeah, I think before we get into that, I think the first question that we asked the UCPLA was, can they sense touch? Because that's probably more important. If they can't sense it, then there's no point. So I think Aranya, you mentioned that they do, and for each person, that sense of touch is either heightened or compromised. So it varies case by case. So with that suggestion, we do hope to play around with like providing some haptic feedback along with like some vision, if they don't have like visual feedback or any other feedback sensations. So yes.
Thank you, Kelvin. Another question was, how do you avoid the training bias that is inherent in these voice assistants? Do you have plans on making your own voice assistant for this application, trained specifically from these users?
So once again, we will definitely validate some things in offline with Stephanie and Aranya. First thing, we need to actually think about privacy. As I mentioned, it's very important for everyone, and caregivers included, feeling comfortable. So there might be a way to go around this. Second thing, some of the assistants, and we talked to the members of Alexa team and others for the accessibility, have an actually available set of accessibility features that need to be activated and validated, but they're already available. So that's also an option. And we saw that we might work in this direction with some additional feedback from Stephanie and Aranya about voice and surveys that we are collecting.
Thank you, Natalia. Next question, was there any consideration given to EEG monitor headsets and leveraging those with software? For example, Muse by Interaxicon, would that work?
Yeah, totally. Actually, PhD in brain computer interfaces here, and definitely actually posted 2 logs on our Hackaday webpage. Don't hesitate to check it. Actually talking about using EEG headsets as a part of my prior work with ALS patients. And we definitely considered this in our preliminary survey. We had 2 responses. People mentioned that they use EEG. So we don't think that it might be the thing we will go for, but there is already a lot of prior work. And one of the projects I worked is on open source. And potentially we can embed it in our app and system. So definitely not excluded. Check out the logs, definitely.
Awesome, thank you. Another question, and maybe this would just need a little more clarification or dive a little deeper, because I do believe you started to cover it in one of your slides, but this person also may have joined a little later. How do you plan on connecting the universal remote to a wide range of products? Maybe you could elaborate on that point.
Sure thing. It kind of goes back to our first overview slide between the physical world and the digital world. The thought was the universal remote would have an onboard wireless system, low power, similar to like Z-Wave. There's a lot of popular smart home systems. And then it would communicate with a smart hub or a smart home system, and then be able to digitize it or connect digitally to the rest of the different items in the world.
Thanks, Ruben. Have you considered developing a standard base that hackers could then design their own 3D printed parts that could attach to the base?
I think that falls along Kelvin's idea. Essentially the joystick method, where, yeah, you would start with a base set of buttons and joysticks, and then you could build off of there.
Thank you. Kelvin, did you want to add anything to that? No problem. All right, we'll keep going. It seems like any technology such as eye or motion tracking, there needs to be an option for an on-off so that users can still have the option to move without something moving. So I guess that's more of a comment or suggestion, but if you guys would like to elaborate on if you've considered that, or how you would differentiate maybe in the different applications of any of these solutions, whether it be the universal remote, the joystick, the app utilizing other devices, etc. How do you differentiate the functions and applications?
Being as it's still in the very preliminary design, we are sure considering a lot of options. There's so many other different options to go off of what Kelvin was showing with the wireless joysticks, the IMUs. There was a project where someone commented, these dots you just place on your skin, and then some device tracks them for amputees. There's so many cool projects out there. And so we haven't nailed down on what exactly we're going to focus on. So keep the comments coming. We'll be sure to include them in our design.
Yeah. So to just add up on that, so like, we could also have like a joystick with, say, like a button. So maybe your like foot is in a certain position. So by slightly altering your slit, or like by lifting up your arm off your armrest, that sort of like is your on-off. That is sort of intuitive to use.
Awesome. Thank you, Ruben and Kelvin. One audience member wanted to highlight to check out iWriter for another awesome open source eye tracker. They use it with an artist to project graffiti they drew onto a building because they couldn't draw. So I love that suggestion. Another question we had was, how are you all designing the survey so that it's accessible? they're suggesting that maybe some community members might not be able to fill out the survey. So that's a question.
Totally. Yeah, we thought about this. That's why so we needed, as you all guys know, and for those YouTube who are watching do not really know, it is 2 months sprint. So we are trying to cover up all the tracks and to right now actually make one more accessibility version available. Definitely right now limited, and we are working in this direction. But certainly if we will make it for the extended period of time, August and even beyond August, we're definitely gonna roll out at least one more accessibility version, for sure.
To build off of that, we understand that many users at this point, before they have the tools in hand, will need their caregivers to help fill out surveys and get us information and feedback. And we're relying a lot on the UCPLA team to help us with that.
Thank you. All right. And then last question was around the privacy. Again, with voice assistants, how do you ensure that privacy is remain intact if you're intending to integrate these other devices?
Yes, for sure. So once again, we didn't confirm yet, will we go with voice assistant or not? That's one of the suggestions, basically built upon the feedback from UCPLA and also the survey. Preliminary results only on 10 users so far actually indicated that all of them can use voice, and it having Amazon Echo and this kind of system. So once again, we will see how we can, if we leverage this communication, how secure it is. And obviously in everything that we are designing and looking at, privacy and what will be collected as data would be the first thing. And we definitely were thinking actually to limit proof of concept, not to using voice assistant that is off-the-shelf commercial available, but have a small proof of concept version to being tested by our users and their caregivers securely in full comfort and without actually going into depth, but showing if this proof of concept even works. So yeah, thank you.
Thank you, Natalia. So that about is going to wrap it up for us today. We're about time here. I want to give a huge thank you to our awesome audience members for those wonderful questions, and to our Dream Team participants, of course, Natalia, Ruben, and Kelvin for their incredible proposals that they presented today. And last but not least, our wonderful mentors and advisors from UCPLA, Aranya and Stephanie. Thank you for your generous contributions and your time that you've continued to give us for the prize and for the dream teams. We're really excited to see how these solutions continue to develop. And if you're wondering where you can find out more about these projects, head to hackaday.io and search for HDP Dream Team UCPLA. You'll be able to follow along their logs and the logs of all the other Dream Team members and their progress there. Also, please be sure to follow us on socials, Facebook, Instagram, and Twitter, Hackaday and Design Lab. You'll be able to see updates on resources, content that's coming out, video interviews, articles, and more. Thanks again for everyone joining in today. It was a wonderful session, and we're going to have 2 more next week with our other 2 dream teams on Monday. So be sure to check those out.